Dear students, under the lecture series on complex analysis, we are solving problems on the topic Taylor series. Already we have completed problem 1 to 5. Now here we have problem 6, which is one of the significant question paper problem. The question is to expand f of z equal to z minus 1 by z plus 1 as a Taylor series about the point z equal to 0 and also about the point z equal to 1. So about the two different points, we have to find the Taylor series expansion of the function f of z given. And also we have to determine the region of convergence in each of these cases. Now let us start with the problem. So first we shall expand f of z equal to z minus 1 by z plus 1 about the point z equal to 0. Now this problem is a little different problem from the previous problems that we did under Taylor series expansion. We will write the Taylor series general expansion and we will incorporate the function f of z into that Taylor series expansion. But in this problem, what we are going to do is, from the function f of z, directly we are going to extract the Taylor series expansion about the given points. For that, first we shall write the given function f of z. So we have written the function. Now we want to expand this into Taylor series expansion about the point z equal to 0, which means that we want to have the powers of z minus z naught in the expansion. So the powers of z minus z naught in the expansion. So we want. So what does that mean? If we want the powers of z minus z naught in the expansion, here the z naught is about the point which is z equal to 0. So here z naught is equal to 0, which means that we want to find the Taylor series, that is the powers of z minus z naught. So if you put 0 here, it is z minus 0, which is z. So we want the powers of z in the expansion. So this is what the required one. So now we shall rewrite this given function so that we obtain the powers of z in the expansion. Now the given function can be rewritten as f of z is equal to z minus 1 divided by 1 plus z, which will be equal to z minus 1 divided by, now this 1 plus z we have, which is to the power 1. Now when we raise it to the numerator, the power becomes negative. So it becomes z minus 1 multiplied with 1 plus z the whole power minus 1. In our previous classes, we have learnt about the binomial expansions. So what does the binomial expansion say? So from the formula of the binomial expansion, we know that from the binomial expansion, we know that 1 plus x raised to the power minus 1 is equal to 1 minus x plus x square minus x cube plus x power 4 minus etc. And this expansion is valid if modulus of x is lesser than 1. So this is from the binomial expansion which we have learnt in our previous classes. So from using this expansion over here, this can be expanded. So this will be, that is f of z will be equal to z minus 1 we will write as it is, and we will expand 1 plus z power minus 1. So by using this expansion, here at the place of x we have z. So replace wherever you have x as z. So what will happen? This will become 1 minus z plus z square minus z cube plus z to the power 4, etc. It goes on like this. And this is valid if modulus of z is lesser than 1. And now we shall multiply this term with each of the terms over here. So first this z we will multiply with each of the terms. So when we multiply, what do you get? So when z is multiplied with each of the terms, first it is multiplied with 1. So z plus into minus is minus, z into z is z square, and then plus z cube minus z multiplied with z cube becomes z power 4, and this series keeps on going like this. And now we will multiply this minus 1 with each of the terms. So minus 1 multiplied with, when minus 1 is multiplied with each of the terms, now first we will write whatever is here, that is 1 minus z plus z square minus z cube plus z power 4 minus etc. Now that is equal to, further this will be z minus z square plus z cube minus z power 4 plus etc. Now this minus 1 when multiplied, you will be having the terms as minus 1, minus into minus is plus z, and then minus z square plus z cube minus z power 4 etc. Now we will combine the terms and we will write. First, the least power of z is z power 0, that is we do not have a z here. We will write that first, minus 1. So this is done. Next, z and z we have. So plus 2z. When added up, they become 2z. Then we have minus z square minus z square. When added up, they become minus 2z square. And then we have z cube plus z cube. So when added up, it becomes plus 2z cube. Also minus z square when added up becomes minus 2z power 4 plus etc. The series goes on like this. So we have obtained the power, that is the Taylor series of the function f of z given in our problem. So this gives us the Taylor series, which is in the powers of z. If you see, we want the expansion, that is the power expansion in the powers of z. That is what we have obtained. Therefore, this is the required Taylor series. Next is we have to find the region of convergence. That is the question. So how to find the region of convergence? Now if you see, this expansion is valid only in this region, that is modulus of z lesser than 1. Therefore, that becomes the region of convergence. This means that it is modulus of z minus 0, which is less than 1 here. Okay, less than 1. So modulus of z less than 1 implies that modulus of z minus 0 is less than 1, which is z naught. So therefore, it is a disk which is centered at 0 with radius 1. So that is the region of convergence. So hence the region of convergence is modulus of z lesser than 1, which is the disk centered at 0 and radius 1. So next we shall do the second subdivision. That is, we have to find the Taylor series expansion about the point z equal to 1 and also the corresponding region of convergence. So now we are going to find the Taylor series expansion about the point z equal to 1. That is, we want the powers of, so we want the powers of z minus z naught in the expansion. So what is z naught over here? Z naught is equal to 1. So this implies that we want the powers of z minus z naught. Here z naught is 1. So z minus 1 in the expansion. So for this, first what we will do is, we will represent this z minus 1 as some w. So let z minus 1 be equal to w. So from this, what is z? Z is equal to w plus 1. So we will rewrite our given function in terms of w now. So therefore, what is f of z given? From the question, f of z is equal to z minus 1 divided by z plus 1. What is z minus 1? We have substituted as w. So it becomes w divided by, now z plus 1 we have here. Z is what? W plus 1. So it will be w plus 1 and then plus 1, which is equal to w divided by w plus 2. So now we can rewrite it as w divided by 2 plus w. And so your f of z will become w divided by, now this 2 can be taken in common, and you will have 1 plus w by 2 within the bracket, because it is 2 and this 2 and 2 when multiplied it will give us w. That's why we are rewriting it as 2 multiplied with 1 plus w by 2. So that is equal to w by 2 multiplied with 1 plus w by 2 the whole raised to the power minus 1. So we want to apply the binomial expansion. For that reason only we are rewriting this and we are bringing in this form. So now we will apply the binomial expansion for this. Now from the binomial expansion, what do we know? So from the binomial expansion we know that 1 plus x the whole raised to the power minus 1 is equal to 1 minus x plus x square minus x cube plus x power 4 plus etc. It keeps on going like that. And this is valid if modulus of x is lesser than 1. Now here at the place of x we have this w by 2. So we can apply this expansion over here. So wherever we have x, we shall write w by 2 over here. So therefore f of z will become w by 2 multiplied with, now here you will have this expansion 1 minus w by 2 plus x square. So w by 2 the whole square minus x cube. So w by 2 the whole cube plus etc. So the series goes on like this. Now we shall multiply this w by 2 within the bracket. And this expansion is valid if modulus of x less than 1. What is x here? W by 2. So w by 2 is lesser than 1. So this will be helpful for us to find the region of convergence. Anyway, now when we multiply this w by 2 within the bracket, we get w by 2 minus w square by 2 square plus, when this w by 2 is multiplied it becomes w cube by 2 cube minus w power 4 by 2 to the power 4 plus etc. So now we shall replace this w by z minus 1. Let us make this make use of this substitution. So w is what? Z minus 1. So this will be equal to z minus 1 divided by 2 minus z minus 1 the whole square divided by 2 square plus z minus 1 the whole cube divided by 2 cube, and then minus z minus 1 the whole power 4 divided by 2 to the power 4 plus etc. So this is the required Taylor series expansion, because we wanted the powers of z minus 1 in the expansion, and hence we have achieved it also. We have the powers of z minus 1 in this expansion, which gives us the required Taylor series. Now we want to find the region of convergence, and we know that this Taylor series is valid if modulus of z minus 2 is lesser than 1. So with the help of this we are going to find the region of convergence. So the region of convergence is modulus of w by 2 is lesser than 1, which implies taking this 2 to the right we get modulus of w to be lesser than 2. Now but what is w? W is z minus 1 from our substitution. So modulus of z minus 1 lesser than 2 gives us the region of convergence. So this is a disk which has the radius 2. So this is the required region of convergence. So which is the circular disk with radius 2. And this is the point z0, which is equal to 1, because we are doing about the point z0 only. Z equal to 1. So I hope you would have understood this problem to the best of your understanding. This is a very significant problem. Thank you.